Imagine sitting aboard a spacecraft bound for Mars, knowing that you will never return to Earth. It sounds like a science fiction movie plot, but this is the brutal reality that every future Mars astronaut may have to face. Based on our current scientific understanding, sending humans to Mars and bringing them back alive to Earth is nearly impossible. The reason is not a lack of rockets or insufficient technology. The greatest barrier is the human biological body itself. That body becomes the heaviest burden of the journey. A mission to Mars is one of the most extreme undertakings humanity has ever attempted. It takes us only 3 days to reach the Moon, but a one-way trip to the Red Planet requires 6 to 9 months of travel. That means astronauts would live away from Earth for a total of 2 to 3 years before they could even think about coming home. During that long stretch of time, their internal organs would be subjected to stresses never experienced in the entire history of human evolution. Distance is only the beginning of the challenge. With an average orbital separation of about 55 million kilometers, Mars is so far away that even light signals take more than 20 minutes to reach Earth. Emergency evacuation is impossible. In the event of a medical crisis, the nearest hospital is 8 months of flight away. These astronauts are completely alone in the vastness of space, without any immediate help from their own species. But the true drama is not the distance or the isolation. It lies in what happens to the human body throughout this journey. A Mars expedition means continuous exposure to 3 entirely different gravity environments. First comes complete weightlessness during months of travel. Then, gravity on Mars itself, only 38% of Earth's. And finally, if they attempt to return, weightlessness once again on the journey home. Each transition is an extreme biological shock. The interaction of all 3 over multiple years produces alarming cumulative consequences. The human body was optimized over millions of years to live on the ground, under the familiar weight of Earth's atmosphere and gravity. When we remove the body from this environment for an extended period, a slow and irreversible transformation begins. Astronauts who spend 6 months aboard the International Space Station often require weeks of physical therapy just to walk normally after returning. Their bones become porous, their muscles weaken, their cardiovascular systems deteriorate significantly. And all of this damage occurs after only 6 months in orbit, where rescue is always possible and Earth is just 400 kilometers away. A Mars mission triples that exposure time, and the level of destruction multiplies exponentially. At that point, the human body is no longer a resilient biological machine. It becomes a fragile structure, struggling to survive in an environment it was never designed to belong to. When we think about the dangers of a Mars mission, we usually imagine technical failures or asteroid impacts. But the deadliest threat is invisible and unavoidable. Cosmic radiation, a constant storm of high-energy particles bombarding astronauts at every moment, day and night. Here, on Earth, our magnetic field and thick atmosphere shield us from 99.9% of this radiation. But in deep interplanetary space, that protective barrier disappears completely. Astronauts would be directly exposed to massive radiation doses, ranging from 870 to 1,200 millisieverts. That is roughly 700 times higher than what we experience on Earth. To visualize the damage, imagine your body undergoing 632 full-body CT scans, or worse, the equivalent of 12,000 X-rays over the 2 to 3 years of the mission. The consequences are devastating and occur deep at the cellular level. Cancer risk increases by 5 to 10%. But that is only the surface of the problem. Heavy radiation particles act like microscopic bullets, shredding DNA structures and destroying healthy cells faster than the body can repair them. The cardiovascular system ages decades prematurely as blood vessels harden under constant radiation exposure. Most terrifying of all is the measurable damage to the brain, the control center of human consciousness. High-energy particles pass straight through the skull, severing delicate neural networks and causing irreversible cognitive decline. Memory deteriorates, thinking slows. Decision-making becomes impaired. Astronauts do not just grow physically weaker, they risk losing their mental sharpness at the very moment they need it most to survive. The eyes also develop cataracts decades earlier than normal, blurring the crew's vision. The immune system becomes severely compromised as bone marrow, the source of blood cell production, is continuously damaged. What makes this truly hopeless is that conventional metal shielding is nearly useless. Increasing the spacecraft's armor with lead or aluminum causes cosmic particles to fragment upon impact, generating even more dangerous secondary radiation. A body exposed to this level of radiation stress for years undergoes fundamental structural change. Radiation is the first domino to fall in a chain of physiological collapse. It quietly transforms humans into something else, even before the spacecraft ever touches the red surface of Mars. While invisible radiation does its damage from within, another catastrophe unfolds simultaneously in the astronaut's skeleton and muscles. This process is gradual, worsening month by month, and represents the greatest physical barrier to returning to Earth. What happens to the body in zero gravity is essentially accelerated aging, except it unfolds not over decades, but within months. The human body is a masterpiece of evolution, perfectly engineered to survive under Earth's constant gravitational load. Every step we take is a natural resistance exercise that maintains bone density and muscle strength. Gravity is both a burden and a sculptor. Remove that burden, and the body begins to dismantle itself. Statistics paint an alarming picture. Astronauts lose between 1 and 3% of their bone mass every month in weightlessness. That may sound small, but the math is brutal. After 6 months, up to 18% of bone mass is gone. After 1 year, 36%. A Mars mission lasts at least 2 years for travel alone, not counting surface time. That means potential bone loss exceeding 50%. For comparison, a 70-year-old woman with severe osteoporosis on Earth may lose only 30 to 40% of bone mass over her entire lifetime. A Mars astronaut, in their physical prime, could return with the skeleton of a bedridden 90-year-old. The most affected bones are the hips, femurs, and spine. These are exactly the structures required to stand and walk. In zero gravity, the body misinterprets the absence of compression as a signal that strong bones are no longer necessary. Bone formation slows dramatically, while bone breakdown continues at full speed. Calcium released from decaying bones floods the kidneys, creating an extreme risk of painful kidney stones in space. Muscles follow the same terrifying pattern. Without gravity, muscle fibers waste away at astonishing speed. Muscle mass declines by 1 to 3% per month, especially in the legs, back, and core. At the cellular level, slow endurance muscle fibers convert into fast, fatigue-prone fibers. While fast fibers may sound beneficial, they are poorly suited for sustained activity on Earth. Astronauts returning from the International Space Station report that even climbing a short staircase becomes exhausting. Joints also degrade. Without regular compression, cartilage and tendons lose their elasticity. Shock-absorbing cartilage thins and becomes fragile, increasing the risk of permanent degenerative arthritis at a young age. Even with 2 hours of mandatory daily exercise on specialized machines, astronauts can only slow this decline, not stop it. Recovery after returning to Earth takes months or years. Many never regain their original bone density. This is the fatal flaw of a Mars mission. 9 months of weightlessness outbound, 18 months under weak Martian gravity, 9 more months of weightlessness returning. The accumulated stress exceeds the body's capacity to recover. Bones become porous like coral. Muscles soften like cotton. Returning to Earth's gravity in this condition is not just painful, it is life-threatening. Bones can shatter simply from standing up. This degeneration is not a temporary inconvenience. It is a permanent structural collapse that makes return impossible. As bones and muscles dissolve, Another dramatic transformation occurs in silence, within the heart. On Earth, the human heart is a powerful machine, constantly fighting gravity to pump blood upward to the brain. This continuous resistance keeps the heart strong. In zero gravity, that demand vanishes. The heart begins to atrophy from disuse. Space medicine studies show that astronauts can lose over 20% of heart muscle mass during long missions. The heart physically shrinks, becoming weaker and smaller. Meanwhile, the entire circulatory system becomes chaotic. Without gravity pulling fluids downward, blood pools in the head and chest, faces swell, legs thin and weaken. The body misreads this fluid shift as excess water and flushes it out. Total blood volume drops by up to 20%. The heart adapts to this lower workload, a fatal adaptation for return. When reintroduced to Earth's gravity, the weakened heart must suddenly pump against enormous resistance it no longer remembers how to handle. Astronauts frequently experience severe dizziness, rapid blood pressure drops, and fainting when they try to stand. After a 2 to 3 year Mars mission, this effect would be magnified many times over. Combined with radiation-induced arterial damage, acute heart failure becomes almost inevitable. A heart that has not worked hard for 3 years is no longer an Earth heart. It has adapted to another world. When all medical data is combined, one conclusion becomes unavoidable. The astronaut who boards the spacecraft is not the same biological entity that survives on Mars 3 years later. Radiation has rewritten DNA. Bones have lost more than half their strength. The heart has degraded into a low-power pump, barely sufficient for weak gravity. This is not simple physical weakness. It is brutal biological adaptation. The human body has transformed into a Martian organism. Forcing it back to Earth is a death sentence. The moment they touch Earth's surface, catastrophe unfolds. Bones fracture under their own weight. The heart fails to supply the brain. A round-trip ticket is a romantic illusion. The first humans to reach Mars will stay there forever, not because the spacecraft lacks fuel, but because their bodies no longer belong to Earth.